Radian measure. Hopefully you're familiar with measuring angles in degrees. There are two ways we measure angles, in degrees and radians. Perhaps radians are new to you. What are radians? Radians are the measure of an angle that is determined by the amount of rotation from the initial side to the terminal side. So however far you go from the initial side to the terminal side is what the measure of the angle is. The central angle of a circle has its vertex at the center of a circle. So what is a radian? 1 radian is defined as the measure of a central angle, theta, that intercepts an arc S equal to the length of the radius of the circle R. So we could define that as R. What does that mean? Well, here is a diagram of a circle with a central angle theta. From center to the edge of the circle, we have a distance of R, the radius, and this curvy distance from here to here. Think if I had a string and I stretched it across here, and then I could hold up the length of the string. Well, that curvy distance here, they're calling it S. We say that that is the arc length. And 1 radian occurs when S is equal to R. Well, there is a relationship that governs the interactions between these 3 variables: the central angle theta, the distance from center to edge of circle R, and the arc length. And that is that S, the arc length, is equal to R times theta. So that will be our first very important formula. S is equal to R theta. So let's take an example where R is 5 centimeters. So of course it's also 5 centimeters here. And our arc length, let's call our arc length the same, 5 centimeters. Well, if S is equal to R theta, and we know R and we know S, let's solve for this angle. The angle will be divide both sides by R, S divided by R, which is 5 centimeters over 5 centimeters. And we get 1, which is unitless. Now, I could say 1 radian. I'll put that in parentheses to let myself know it's really unitless. You see, the units cancel. And that's what this is. It's 1 radian. 1 radian is defined when R is equal to S. And this relationship always holds provided that theta is in radians. It doesn't hold for degrees. We must put it in radians. Now, 1 radian is about equal to 57 degrees. If you need to hang your hat on something, we can say it's about equal to 57 degrees. Notice I use these curvy signs because it's not exactly 57 degrees, but we have a unit of about 57 degrees. If I have this circle here, I can say that this is 1 radian, and this is 1 radian, and this is 1 radian. Well, what's left here? It's about 0.14 of a radian. What? Well, in half a circle, we have pi radians, and pi is, you should know, the circumference divided by the diameter of any circle, and that comes out to this irrational number that's about 3.14. So in each half circle, I get about 3.14. If I went clockwise here, I'd have 1, a 2, a 3, and this little wedge of cheese here is 0.14. So in 1 full circle, you can see that I have about 6 radians. 1 circle is about 6 radians. I can do better than that though, can't I? If this is pi 3.14 and this is pi 3.14, if I add 3.14 to 3.14, I get 6.28. So this little distance here that makes up for the difference between the actual number of radians in a circle and my estimate is about 0.28. So I'm still going to use about. 1 circle is about 6.28 radians. Well, in degrees is about 360 degrees. Half a circle is pi radians, which is about 180 degrees. Actually, it is exactly 180 degrees. So that means once around a circle is 2 pi. If I take this angle here in standard position, that's 2 pi, which of course would be 360 degrees if you're more familiar with that. Let's compare measuring an angle in radians and degrees. Well, hopefully you know that. If I'm going counterclockwise here, that's a positive angle, and both my initial side and my terminal side are the same. So I go all the way around the circle. I've gone 360 degrees. If I do the same angle in radians as we just saw, that's going to be 2 pi radians. On a similar note, if I do, I'll put a cross in these, if I do 1/2 of a circle in degrees, we say that this is 180 degrees. If I do the same angle in radians, well, if once around the circle is 2 pi, then 1/2 of a circle is pi radians. So these are good to know. Immediately, the quicker you get these down, the easier your life will be. 2 pi radians is 360 degrees. 1 pi radian is 180 degrees. If you're with me so far, this should look familiar. Pi radians is 180 degrees. Well, what if I split that in half and I said, I don't want to go all the way to pi. Notice I'm going counterclockwise, which is a positive angle. I'm going halfway there. Well, of course, that's pi divided by 2, or 1/2 of pi. If I'm going halfway to 180 degrees, I've cut 180 in half, so that's 90 degrees. So there's a good equivalency as well. Pi over 2 is 180. I love radians. They're so easy to work with. I cut pi in half. What if I cut pi 3 ways? Well, if I cut it up 3 ways, then I'd have pi divided by 3, pi divided by 3, pi divided by 3. Similarly, if I cut this 180 degrees 3-way, well, we know 180 divided by 3 is 60 degrees. So each of these will be 60 degrees, and we've got a new equivalency. Pi over 3 is equal to 60 degrees. So those are 2 good ones you've got to memorize. Pi over 2 is 90 degrees. Pi over 3 is 60 degrees. You could always draw pictures and prove it to yourself. Now, what if I take this counterclockwise angle out to pi radians and I cut it up 4 ways? I love radians. They're so easy. Cut it up 4 ways, then each of these little wedges of cheese here is pi over 4. If I cut 180 up 4 ways, each is going to be half of 90 degrees, or 45 degrees each. So here's another wonderful equivalent that you should have in your hip pocket at all times. Pi over 4 is equal to 45 degrees. Here's our last one, everyone's favorite. If I cut pi radians, I'm going counterclockwise, positive angle, over to pi. If I cut it into 6 little wedges of cheese, each of these angles is, you guessed it, if I cut pi up 6 ways, each is pi divided by 6. Now, if I do the equivalent in degrees, 180, if I divide that by 6, I'll get 30 degrees. So each of these little wedges of cheese over here are 30 degrees. So there's our last equivalent that you should have down, backwards, forward, upside down. You should know that 30 degrees is pi over 6. You must know by heart. Here's your starter set, radians and degrees. 2 pi is 360 degrees. 1 pi is 180 degrees. Pi over 2 is 90 degrees. Pi over 3 is 60 degrees. Pi over 4 is 45 degrees. And pi over 6 is 30 degrees. Notice there's no units on this side, but if I mean degrees, I have to put a little degree sign. Recall that the 4 quadrants in a coordinate system are numbered 1, 2, 3, and 4. A 1, a 2, a 3, a 4. Quadrant 1 includes acute angles if we're doing angles that open counterclockwise and are positive. So over here we've got acute angles when the angle is between 0 and pi over 2. Remember, that's 90 degrees up here. If the angle opens into the second quadrant, we call it obtuse. And that means the angle is between pi/2 and pi. In quadrant 3, we've got a huge angle, and that means our theta, counterclockwise, is between pi and 3pi/2. Notice pi is over here, 3pi/2 is here. Why? Because that's the halfway between pi and 2pi. And quadrant 4 is between 3pi/2 and 2pi. Notice as we come around the circle, theta over here again is going to be 2pi. So it'll be 0 and 2pi over there.